Yeah, Nabil, are you doing?
Yes, sir.
Okay. And is it visible to you on your screen, the question? What
Yes,
is
sir,
it?
I can see.
So, hello, Romaisa. How are you? Is I'm audible to you?
Hello, sir. I'm fine. How are you? Yes, sir. I can hear you.
I'm fine. It has been so long that I have not teach you and not seen you. So,
Yes,
where were
sir.
you? Why were you absent in the yesterday class? Hey, Romaisa. Why were you absent?
Yes, sir. I was outside.
You were outside. Okay, beta. So, do this question, please. Do this question.
Okay.
This question number 12 on your screen.
So is it 28?
You're saying 28. No, it is asking that how much grams of, how it is 28? It is not
Well,
28.
mm, we should find the amount of N2, right?
Hmm. Should I help you? Romaisa, you done?
No, sir. I'm doing.
Do it, and then both of you will discuss this one, okay?
Sir, can I just go for 5 minutes? I'll be back. Just
Okay, go.
thank you, sir.
Sir, I got 68.
68. Yeah, 68 is the correct answer. So let's record this, how it is done, okay? So, you know that this is a very simple question. Whenever this type of question is being asked in the examination, you have to simply write the formula, okay? Ammonia gas. Okay, so if ammonia gas is formed, you have to find out the ratio of the ammonia, right? What is the ratio of their masses? Okay, and here it is saying that nitrogen and hydrogen ratio is 14 is to 3. Okay, so nitrogen when react with hydrogen gas, when react with hydrogen gas, okay, then it is going to give you ammonia, and the ratio for this one is 14 is to 3. Okay, so how if 14 gram this react with 3 gram this. So according to the law of conservation of mass, the total mass should be conserved. Okay, so 14:3 ratio is given. So total 17 grams of ammonia is going to form. Now it is asking that if we have to produce the from these 68 grams of, okay, now 68 grams of ammonia is formed. Okay, then it is 68 grams of ammonia. Then it is asking that how much grams of nitrogen gas is being required. How much grams of nitrogen gas? So we need to find out this one. So this is very simple, that what you need to do is just you are going to ask the relation between this one and this one is given to you. Okay, so just take the relationship of this one 14, and let this is x gram of hydrogen gas will be required. Okay, so nitrogen gas will be required. So write it 14 by x is equals to 17 by 68. Write in the fraction, this upon this is equals to this upon this. Now you can do the reciprocal also, or you can cross multiply these two like this way. Okay, this it's your choice. Okay, so here what you are going to write it 17 ones are 17 and 17 4 the 68. Okay, now this 4 will goes to this side and this will go to that side, so you will get x is equals to 14 into 4. You will get x is equals to 56. Okay, so here the nitrogen is being required, the amount of nitrogen that is being required for making the 68 grams of ammonia gas, it will be 56, and rest the amount of will be hydrogen will be required. So if I ask you that how much amount of hydrogen is required, so write it 68 minus 56. Whatever the answers comes, you will write it 12. Okay, so this is a simple. Other way for making this one is that by what number should you multiply this 17 to get exactly 78? Okay, 68, sorry. So you have to multiply it by 4. So here you have to multiply this number also by 4. So you can also get it that the same 56 answer will come. So this is the way that you can do this question. Okay, got it?
Yes, sir.
Got it? If I ask you the next question, uh, yeah, we have done this questions in the previous class also. So let's check whether you learned this one or not. Ira, you there? Sorry, Arya.
Yes, hard network issues.
How are you?
Uh,
Are you fine?
I'm good, sir. How are you?
I'm also fine. So here this questions again on your screen. Please do this one.
Is it 9?
What are you saying? 9. Arya, you did this question in the previous class.
No, that's Nabila.
Nabila is here, na? Arya did this question in the previous class. He was present yesterday.
Yes, sir.
And you are you able to do this one?
Yes.
So what's the answer?
0.9.
0.9. And you were saying 9. Nabila, you were saying 9.
Yes, sir.
And Rumaisa, what's your answer? What's your answer?
So
Tell me.
0.9, so
Hmm?
got 0.9.
0.9. Yes, it is correct. Okay. So here, how can we make this question? Just a minute. Okay. Here is the questions on your screen. And how will you answer this one? That let me explain you. That it is saying that when the combining ratio of carbon and oxygen is to form carbon dioxide is 3:8. So this is carbon and this is oxygen. When they combine together, they form carbon dioxide, CO2. And you know that the combined ratio is 3:8, means for every 3 grams, 8 grams of oxygen is required. It does not mean that for every 3 grams, 8 grams will be required. If we have 1.5 gram, then the reaction will not take place. It does not mean. It means that if we have 3 grams, then we require 8. If we have half of this 3, then we will require half of this 4. If we have half of this 0.75 grams, okay, then we will require 2 grams. The ratio will be same every time. Got it? You understood?
Yes, sir.
So we have to write it accordingly. Okay. So here it is saying now that for the we have 2.4 grams of oxygen, then how much grams of carbon will be required? So it is asking how much grams of carbon will be required. So what you are going to do, just in the previous step that we did, write 3 by x, this upon this will be equals to this upon this, yani 8 upon 2.4, and just cross multiply this to get the value of x. This you will write it, don't multiply it like here, 2.4 okay, is equals to 8 into x. Okay, now this x will comes down and this will be 3 into 2.4 upon 8. You cut it, you will get 0.3. Okay, 8 3 is 24. If it is 24 upon 8, it will be 3, but it is not 24, it is 2.4 upon 8, so it will be 0.3. So when you multiply x into 0.3 into 0.3, so you will get 3 3 is 9, but you have to place the decimal after this one. Okay, you will get the x is equal to 0.9 grams. Okay, you understood this one?
Yes, sir.
Okay, so let's check. Uh, is there any doubt in the questions that you are facing in any other topic of this chemistry? Let's check some
Yes,
important
sir.
questions. Can you tell me where you are facing?
So I'm facing doubt in Rutherford's theory and Bohr's theory.
You are facing doubts in Rutherford and Bohr. So let's do the questions regarding to that one, na? Or should I explain you that theory first?
Can you explain it briefly?
Yes, why not? Why
Thank
not? Just a minute. Bohr and Rutherford model, na? You are talking?
Yes.
Okay, okay, just a minute. Just give me a second. Take the example. So what actually happens in the screen is not visible to you now? Is the screen is visible to you now?
Yeah.
Hmm? So when Rutherford was doing in his experiment, let me explain you that when Rutherford was doing his experiment, he bombarded the helium helium-2 positive ion, which we called alpha particle. Alpha particle. We called it Rutherford uh, alpha scattering experiment. Okay, alpha scattering experiment, known as Rutherford alpha scattering experiment. Okay, alpha scattering experiment. Okay, so what happens here is that in the Rutherford model, okay, if I talk about, so when Rutherford was doing his experiment, which is known as Rutherford alpha scattering experiment. So what when he was doing this one, okay, what he does actually, he took a gold foil. Okay, he took a gold foil. He took a gold foil, very thin gold foil. Okay, which were having atoms. Okay, alpha particle emitter. So actually, when he was doing his experiment, what he does here is that when he passes the alpha particle, what are alpha particles? Alpha particles are those particles which are when we have helium atom. Let's suppose we have helium atom. Helium atomic number is 2. It has 2 electron in its outermost shell. Okay, and mass is 4. Helium has 2 electron in its outermost shell and first shell also, and has 4 mass. If the helium atom loses both of its electron, it will become helium-2 positive. Like sodium, when loses one of its electron, it becomes Na1 positive. Na1 positive means 2-8 electronic configuration. So when it loses both of its electrons, become helium-2 positive. Now you imagine that if it is not having any electrons, so what does it mean? It simply means that it is going to have only nucleus. It is going to have only nucleus of helium. So nucleus of helium, which is carrying 2 proton and 2 neutron, that is called helium-2 positive. Helium-2 positive, and it is called alpha particle. Alpha particle. Okay. So when he passes the through it, okay, he noticed that most of the alpha particles go undeflectedly. Most of the alpha particle, he was the first observing that the most of the alpha particle go undeflectedly. They were moving on the straight path. Some of the alpha particles deflected at some small angles. Some of the alpha particle deflected at small angles. Okay, some of the alpha particle deflected at small angles. He noticed this one. And a very few means we will simply say that 12 means we can simply say that 1 out of 20,000. In some books it is a 20,000. In some books it is written as, okay, it is written as if I talk about 1 out of 12,000. Okay, it's been goes, no? 1 out of 12,000. Got it? So it is visible to you now?
Yes, sir.
Okay. So he said that most of the alpha particle passes through the gold foil undeflectedly. Okay, most of the alpha particles goes undeflectedly. Some of them means some of them get curved or bent at small angles. Okay, some of them get bended at small angles, and 1 out of 12,000 get rebound back to its original path. There you can see that here this particle is coming back. Okay, this is bonding. So it simply means, the first means that most of the alpha particle goes undeflectedly. It means that the atom is going to have a lot of empty space. Okay, atom is going to have lot of empty space. Uh, okay, through which alpha particle can pass without any deflection, because gold atom is very bigger in size as comparison to that of helium nucleus, because alpha particle is helium nucleus, na? Okay, so gold atom is very large as comparison to that one. Got it? So because of that, it can pass through it easily, because atom is means it has lot of empty space, and it is only the nucleus. So nucleus is very very small in size, so it can pass easily through the atoms of gold, okay, without any deflection. Now, one out of 12,000 is rebonding back. So it means that when there is some, he said that there is some positively charged substance present in the nucleus. There is some hard and dense mass is present at the center of the atom through which alpha particle cannot penetrate. There is something very hard and dense present in the center of the atom. Which he called nucleus. So the discovery of the nucleus was done by Rutherford. Got it? Discovery of nucleus
Yes.
was done by Rutherford. Got it? The discovery of the nucleus was done by Rutherford. Okay, got it?
Yes.
So and since one a minute fractions of alpha particles suffered deflection, means one in a, we can say, very very last, means so it is deflected with some small angle. What does it mean? What he concluded when it is, so it is saying that there is some charged particles, because now alpha particle is charged particle which is going to have He2 positive charge, and nucleus is also positively charged. So when a positively charged come closer to the positive charge nucleus, so it will rebond to it, because positive repel each other. Or if it is, there is electron here somewhere, and if this is positively charged particle it is going, so electron is negatively charged, so it will be attracted towards it. So due to there is some charged particle present in the atom through which alpha particles get attracted or repelled when repelled by the nucleus, because nucleus is carrying positive charge, electrons are the negatively charged, they will attract the helium particles. So because of that there is a deflection is being seen. Got it? Got it?
Yeah.
So since deflections are very few bounce back and lead to the conclusion that most of the space in the atom is empty and the space occupied by the nucleus is negligible. He said that nucleus is very very small, it is negligible, but the whole mass of the atom is concentrated there because it is very hard and dense substance through which alpha particle cannot penetrate. For example, if because you know that gold, if I compare, the gold is going to have mass 197, okay, and helium is going to have mass only 4 4u. So just imagine you are having a 4 kg substance and you hit a, like you just imagine that you are having a stone in your hand and you hit a car. Will the car repel to this one, or will bounce back the that stone towards you? Okay, so similar things happen because when the alpha particles are moving and striking the nucleus, they are striking the nucleus, then they are rebonding back. This means there is something hard and dense present in the nucleus through which alpha particle cannot, even the alpha particle cannot penetrate. You understood?
Yes,
Understood?
sir.
So these are the conclusions that the whole mass of the atom is concentrated in the nucleus. So I'm just underlining the important part. Okay, write down all the 4 points, these 4 points in your copy, please. You also, Nabil, and other students, please note it down.
Yes.
1, 2, 3, 4. Let me underline. Let me short this one. The atoms consist of nuclei and large. This is the whole point that you have to write. Atoms contain solitary charge nucleus. Uh, a few particles suffer deflections and a very few. This is the second point. Don't write this. And third point, since a minute alpha particle suffered deflection and a very few. Write down only this part. Here you have to write the reflections conclusion. You have to write it that uh, since a minute friction or minute frictions of alpha particles suffer deflection, it means that there is something charged particle present in the atoms, indicating indicating there is some charge particle charge particle present in the atom. So which alpha particle is reflected? Okay, note it down, please.
Done. Noted.
Yes, sir.
Everybody in the class, noted?
Yes, sir.
Why are you not replying that we have done this one, sir?
Yes, sir.
Okay, just a minute. Have you rotated this one that the whole mass of the atom is concentrated in this one? Okay. So on the basis of his observation that he gave, he said that atoms revolve around atoms contain of centrally positively charged nucleus, he called. Now, structure he need to give now where he was doing experiment. So when he was doing experiment, so it means that he need to give the structure for this one. So he said that atoms revolve around the nucleus. Atoms revolve around the nucleus in a well-defined orbit. Well-defined orbit concept comes like that from the solar system. Like the sun is at the center, and he considered it like a nucleus is at the center in the atom, and like the planet revolve around the sun. Similarly, electrons revolve around the nucleus. So what he said that according to his model, he says that there is positively charged nucleus in the atoms, and nearly the all mass of the atom residue there means neutron and protons lies in the nucleus. And he said that electrons revolve around the nucleus in well-defined orbit. Okay, the size of the nucleus is very small as compared to the size of the atom. So please note this also. Well-defined orbit indicate that it is similarly referred to this means his structure was similar to that of solar system. Okay, got it? Note it down, please.
So for exams, will balancing the equations come? Because we learned and my teacher said for law of conservation of mass, it could come, and in general also.
Means law of conservation of mass could come in your examination, na?
Yeah, to prove that balancing equations will come.
Balancing chemical equation में
Yes.
But the balancing of chemical equation is in 10th standard, na? You don't know, you are not going to write the chemical equation. So easy chemical equations can come.
No, because she gave us 20 chemical equations.
So send it to the team. Okay, and they will send it to me. Okay, so
So,
send it to the team. They will send it to me, and then we will do this one in the next class. Okay, you are going to have final exams now this time.
on Monday, so
You are going to have Monday. Monday is your final exam.
yeah, of science. From Monday it's starting.
Okay. Okay, we will learn it to balance the chemical equations. Okay. Okay. This is only the 10 to 15 minutes are left. So how can we do this one? Okay. We will do this in the next class. Okay. Don't worry. Monday is very far away from us. Here it is. If I talk about the drawbacks of Rutherford models, what are the drawbacks of Rutherford models? That according to Maxwell theory of electromagnetic induction, or according to Maxwell theory of electromagnetism, he says that when a charged particle like electrons, okay, revolve around the nucleus, then it will definitely lose its energy. So when something is losing its energy, then like you see that we have a mass object, and if it is something pulled down and we rotate it, so it will spiral like this and comes closer to the center. So similarly, the electron will loses its energy, it will come closer, it will take a spiral turn, will come and hit the nucleus. And when it hit the nucleus, then the structure of the atom will automatically disqualified. Okay. So according to Rutherford, electrons revolve around the nucleus in well-defined orbit, but electrons being charged particle and will lose its energy and will finally fall into the nucleus. So this was the theory of How you can say that it will lose its energy? Because it is a theory of that was given by Maxwell. So Maxwell said that when a charged particle revolves, then it loses its energy. When even though charged particle when it accelerates, when it is moving, it loses its energy. Okay. So similar that electrons being charged particle will lose its energy and finally fall into the nucleus, and this make the atoms unstable. So this was rejected. Okay. This was the main drawback. Because of that, he was not able to explain. Okay. Understood?
Yes.
Take the screenshot of this one if you have not taken this one. Take the screenshot of this one. You remember the drawback? Hmm? Tell me fast.
Yes.
Rumaisa and Nabila, are you getting this one?
Yes, sir.
Yes, sir.
Let's do the next part of this one. Now the Bohr model comes into the context. So what was the Bohr model? Okay, let's see. Azan is over. Okay, just give me a 2 minutes. 1 minute wait. Okay. So here in this one, that you see that in the Rutherford model, okay, Neil Bohr was the one that this question may become that who give the Rutherford model in the MCQ. So Neil Bohr was the one who gave the that's why it is called Bohr model. In 1912, he gave this one, and what he said that this time he said that atoms revolve around the nucleus in a fixed energy shell, in a shell, and they have fixed energy. They neither gain energy nor they lose energy when they are in the orbit. Okay, and this he said that on a certain special orbit that atoms revolve around the he gave some assumptions. There was an assumption that he took that electrons revolve in the special orbit which he called discrete orbit. Okay, and that the electrons is revolving in a fixed orbit. Okay, they are revolving in the fixed orbit when the atoms either jump from inner orbit to higher orbit or higher orbit to lower orbit, then there is a change in energy is going to take place. And here it is represented that when it is jumping from inner to the outer to inner orbit, then it is releasing the energy. The release of energy will take place when then the electron is going from higher to lower orbit. And when it is jumping from inner to outer orbit, then the absorption of energy will take place. Okay, so this is the diagram that will help you to understand more betterly. While revolving in discrete orbit, the electron do not radiate energy. When it is revolving in its energy, radiate means release. When it is moving in its energy shell or orbit, which we call shell or orbit, it neither gain nor lose energy. Then energy will remain fixed as it is. Okay, the energy is emitted and absorbed by the atoms when an electron moves from one orbit to another. Like there is a change in energy will take place when it is jumping from one orbit to another orbit. You understood?
When it goes from inner to outer, it gains energy, right?
Yeah. Okay. When it loses, then when it comes from outer to inner, then it loses energy. Okay. Got it? Got
Yes.
it? And he gives a way that how the atoms are arranged, electron distribution, and he called Bohr-Bury scheme. According to him, he said that the electrons revolves around the nucleus, but there cannot be any number of electrons that can lie in the shell. There can be a fixed number he gave, that it was given by 2n square, where n is the number of shells, 2n square. If you want to know that how many electron can lie in the first orbit, put the value 1. 2 into 1 square, you will get 2 into 1 square is 1 is 2. The first shell can have 2 electrons. Similarly, when you put 2 square here, in the second orbit you can check 2 into 2 square is 4 is equals to 8. In the third orbit is 3 is equals to 2 into 3 square is 9 into 18, and then 32, and then so on. So here uh, he was saying that the first orbit can have maximum 2 electrons, the second orbit can have 8, the third orbit can have uh, 18, and the fourth orbit can have the 32 electrons. But if it is if it is the outermost shell, except the first shell, the second shell, third shell, fourth shell can have maximum 8 electrons if they are the outermost shell. Like for example, if I'm having 2, 8, 2, 8. So you know the second shell can have maximum 8 electrons. So if the next electron comes, then it will comes to this one. Now if it is 2, 8, 8, it is filled. 7 more electrons are here. Okay, now it is the third shell. You know that third shell can have 18 electrons. 18 electrons. The third shell can have 18 electrons. But if the extra electrons here comes like 2, 8, it cannot have 9, because now it is the outermost shell, and the outermost shell cannot have outermost last shell. It cannot have the 8 electrons. Sorry, more than 8 electrons. So to overcome this rule, it cannot have 9 here. So what does it do? It will have 2, 8, 8, and then it will come 1. The next electron will come in the next shell. Unless and until it will be 2, 8, 8 here, then 2, 8, 8, 2, 2, 8, 8, 3, 2, 8, 8, 4, 2, 8, 8, 5, 2, 8, 8, 6, 2, 8, 8, 7, 2, 8, 8. Then it is the outermost shell. The next electron will come in this one and will remain the as outermost shell. This 9, then 2, 8, 2, 2, 8, 10, then 2, 8, 11, 8, okay, 2, 8, 12, 8, 12, up to 18 it will keep on going like this. So the outermost shell can have maximum 8 electrons. Okay, got it?
Yes.
Got it? So this is very important. The outermost shell cannot hold more than 8 electrons, while the second shell can't have more than means 8 electrons. Second shell, you know that it can have more than 8 electrons. Then okay, third shell can have 18, but if it is the outermost shell, it cannot have. First the fourth shell should fill, then the next electron will come in this one. Okay, the outermost shell cannot hold. So this is the way that Bohr-Bury scheme represents you. So note the second and third points. Second and third points. Don't write this one. Don't write this one. Particular shell. Only write it up to this one, up to here. The first point and the second point. This one. Please note it down. This is important. Noted?
Yes.
Sure.
Yes, sir.
Everyone, let's take the examples of this one. Okay, just a minute. Let's take the examples that how much you have learned. The screen is visible to you? No,
No.
it is. Okay, is it now?
Yes, sir.
Oh, I have to download the what I'm doing here. Just a second. Structure of atom. Okay, just change this one. Is it visible? Now it is visible to you. Okay. Tell me that which one is the correct option in the question number 10. In this question number 10, which one is the correct option? Can you tell me? Hmm?
A.
A. You, Gamaisa, what's the answer? Gamaisa,
A, sir.
why A? It is magnesium 2 positive, na? So it must have loosened 2 electrons. Magnesium 2 positive. So it is 2A2 is normal magnesium. So it will lose its 2 electrons. Then it will become magnesium 2 positive. So it must have 2 shells. First shell and second shell. This is the correct option. This will be rejected because it is having 3 shell. It will be also rejected because it is having 3 shell. It will be rejected because it is going to have 3 electrons in the first shell. So D is the correct option. Understood?
Okay.
You understood, Nabila? And you?
Yes.
Yes.
Okay. Tell me. Question number 16, which is the correct option? Question number 16. Which is the correct option? Question number 16.